everyone, welcome back to the TechArt Learning Hub. I'm Preeti Boddeti and today we are diving into the fundamental concept in natural language processing, that is tokenization. What is tokenization? It is the process of breaking text into smaller units called tokens. These tokens can be words, subwords or characters depending on the tokenizer used. This tokenization is an essential step in preparing text for the machine learning models. Why is this tokenization so important? It is important for understanding language and for efficient processing. Language models cannot understand raw text directly, so tokenization converts this raw text into numerical representation which they can understand. It helps models analyze and generate text efficiently by breaking it into manageable pieces. In simple terms, tokenization makes it possible for the AI models to read and understand text. Now let's move on to implementing tokenization using the pre-trained tokenizer from Hugging Face. Before doing the implementation, I just want to give you all a quick note. You need to set a few environment in the Google Colab before we start the implementation. The first one is the access credentials that we have created in the Hugging Face in our previous lecture. If anyone who did not follow the previous video, please check out the pipeline implementation video where I have mentioned how to create an access token in the Hugging Face and how to use those credentials in the Google Colab. Now let's start the implementation. So let's start with the import statements. So I would say import statements. So from google.colab import user data. Okay. From Hugging Face Hub import login. From transformers import auto tokenizer. You must be knowing the first two import statements as we have used them even in the pipeline implementation, the previous lecture, but I'll just tell you all again. The user data is used in the Google Colab to retrieve user credentials securely, and the Hugging Face Hub import is to log into the Hugging Face to access models, and the new import statement is from transformers import auto tokenizer. This loads the auto tokenizer from the transformers library that loads the pre-trained tokenizer for different AI models. In the previous lecture, we also imported from the transformers library, but that is pipeline, as you all must have remembered. So that is the only difference we have from the pipelines and the tokenizer. So next, moving on, is we will log into the Hugging Face and then start the tokenization process. Now let's start logging into the Hugging Face. So log into Hugging So I would say HF token, we are going to retrieve the HF token that was in the credentials. So user data dot get of the HF token variable. Now using this token, we are going to log into the Hugging Face. So login of the token. So let's execute this. I have given this, okay, it's HF token. Yeah, we have successfully logged into the Hugging Face platform. Now we have to load a pre-trained tokenizer for some specific model. So to do that, I would say as we are going to load this pre-trained tokenizer using the auto tokenizer. So example, let's give a comment, load pre-trained tokenizer. So I would say tokenizer is equal to auto tokenizer dot from pre-train. We have to give a model name so that we can load a pre-trained tokenizer using the auto tokenizer, that is with respect to a model. So I have already searched a model. So this is the Meta Llama 3.2 11B Vision Instruct. You all can take any of the model of your choice, but I have taken this. Sometimes we need to take access permission, so you all just take the permission and you all can directly use it in your implementation. So what I would do is I would copy this model name and I will mention it in here. So this is the model name, and then we are going to give as trust remote code is equal to true. This is an additional parameter for the auto tokenizer. This parameter tells the pre-trained tokenizer to trust and execute the remote code with respect to the model name given. So this is all about loading a pre-trained tokenizer using the auto tokenizer. Now next we will be using this tokenizer that has been loaded. For now, let's start the encoding and decoding with the loaded pre-trained tokenizer. So with some random text, so let's say as encode and decode. So I'm just going to give text is equal to let's work on encoding and decoding using pre-trained tokenizer. So now we are going to give as tokens is equal to tokenizer dot encode the text. So what this line of code represents is the tokenizer is the loaded pre-trained tokenizer for the respective model name that we've given, and using that we are converting the mentioned text as an input into smaller pieces of tokens, because the model understands only the tokens that are represented in numerical format. So let's print these tokens and see how they are represented. So print of tokens. So I'm going to run this code, and if you all can see, we have an array of tokens. List of tokens, 1280000, 10267 So these numbers 1280000, it can be let's, or it can be let, or it can be let's with the space, or let's work. It could be anything. It depends on the tokenizer and how it takes the characters in the text, and which set of characters belong to one numerical number. So if I could say, let's for example take the length of the tokens. So I would say print length of tokens. Let's run this and see. Okay, it is 13, and I would say again print length of text. Yeah. Okay, it is 64. So I would say as maybe one token is equivalent to the 4 characters or 5 characters. It could be even the special characters as well, like spaces. So it is that the comparison which I am making, like what one token could be, how many characters it could contain. It's just a guess. So yeah, let's again decode it and see how it's working. So again let's say let's delete this. Yeah. So now let's do the decoding for the same text. Okay, so again we will be using the tokenizer. So decoded text is equal to tokenizer dot decode, but the input is the tokens, and let's print the decoded text. Yeah, we got the same. Let's work on encoding and decoding using pre-trained tokenizer. It has even given a period at last and also the apostrophe. It is exact the same text which we have given. It has given us the same input. So that's all about the encoding and decoding with the tokenizer. Next we will move on to different types of tokenizer and how they work. Now I would like to show what set of characters it has taken to be considered as a token. I would just show you all with an example. For say batch tokens is equal to tokenizer dot batch decode of the tokens. Let me print these. So print batch tokens. So if I run this statement, y'all can see we have the set of characters that were represented as tokens. For say the begin of text, let's talk about this later. So here we have let as one token, apostrophe s as the other token, and one of the token is space and work, space and on, space encoding, space and, space decoding, space using, space pre hyphen trained, space tokenizer, and a period as the other token. So these are the characters that were considered as tokens. And if you all have noticed this begin of text, this was also considered as one of the token, and that is the reason we have 13 tokens, not 12 tokens, because if you count our input text that we have given, we have 12 tokens, but when we have printed the length of tokens, it has given 13 because it has included even the begin of text. This begin of text is one of the special token from the tokenizers, because few of the tokenizers would love to append their special tokens for their understanding the context. So here for our input text, it has prepended with begin of text special token, so that it can understand, okay, yeah, this is the beginning of the text that they have given, and I have to encode it and I have to decode it and so on. So that is why it has included this special token as well. If you all do not want the special tokens to be added, so I would say as add special tokens is equal to false. For example, if I just run this code again, and if you would print the length of tokens, it would be 12, because I have given add special tokens to false. It means do not include any special tokens when encoding. So if I run, you all can see, right? So it has given 12. And now if you all just run this code, you will just see only from let to the period. We will not have any special token again. So if I just run this code, see, the special token has been removed. So this is all about the encoding, the decoding, and how many characters it has taken for the tokens, and what are the special tokens, and so on. Yeah. Next we will move on to different types of tokenizers, and we will work on their implementation. So the first one, we'll start with the fee by Microsoft, and then the Quen. So let's move on for the implementation. So first I would say different types of tokenizers. So the first one is free tokenizer, and we are going to load it by auto tokenizer. So tokenizer dot from pre-train, going to mention the model. So here is it. So I'm just going to copy it and going to mention it in here. The same way I'm just going to copy the quen, and let's say it as quen tokenizer is equal to auto tokenizer dot from pre-train, mention the quen. And we also have the llama, so we are going to use that as well. For now I'm just going to run these 2 lines of tokenizers, and then we are going to use these tokenizers to encode and decode the given input. So the loading is successful. Now let's move on to the random text. So I would say text is equal to, I would give the same text. So let's work on, so let's use this. Now I'm going to give as tokens is equal to 3 tokenizer dot encode the text. Okay, and next we are going to give as quen tokenizer dot encode text. So I would not mention this as well. Now let's print these tokens. So print fee tokens and print quen tokens. I don't know why I got this error. Quen tokens is not defined. Okay. I think now it's gonna work. So if you see let's print the length of this. So I would say print length of tokens and print length of quen tokens. Let's run it again. So if you can see, we have for the fee model we have 17 tokens, and for the quen we have 12 tokens, and for the llama we have 13 tokens because we have the special characters too. So let's again print, okay, let's say as batch fee tokens is equal to fee tokenizer dot batch decode fee tokens. The same way batch quen tokens is equal to quen tokenizer dot batch decode quen tokens. Let's print this. Print, oops, okay, let me run it. Batch tokens print match Quen tokens. Let me run it again. Where did I go wrong? Fee tokenizer is not defined. Okay, it's 3. Yeah. So if you can see here, there are no special tokens added that were appended for our input text. So if you can see, it has taken let apostrophe as one token, s as the other token, and work. So there are different ways for depending upon the tokenizer, it takes that particular characters as token. For fee 3, it's different way of taking the characters into tokens and representing them. And for the Quen, it is another way of taking some set of characters and converting them to a numerical representation. So always the tokenization process is the same, where it converts the raw text into a sequence of numbers, but the pattern differs. Like one tokenizer takes 3 characters, one tokenizer takes 2 characters, one tokenizer takes just the special characters. It depends on how it takes the set of characters as tokens. So this is all about how the different types of tokenizers work in their implementation of tokenization. Next, we will move on how the tokenization works when doing the coding process. Now let's start the implementation of the code tokenization. So I'm going to use the star coder from the big code, that is a model. So I'm going to say as star coder tokenizer is equal to auto tokenizer dot from pre-train. I'm just going to mention that model name that is responsible for the code. So that is the star code of big code. So I'm mentioning this, and then we are going to have another additional parameter as trust remote code set to true. So we have loaded the pre-trained tokenizer that is responsible for tokenizing the code, and what more best model is used, that is big code star coder. So I have loaded this tokenizer, and now I'm just going to mention the code that it has to tokenize. So definition hello world, I would give person as a parameter, and then print hello person. Next, let's encode it using this tokenizer. So star coder to underscore tokenizer dot encode the code. So now it's going to generate a list of tokens. So I would run a loop. So for token in tokens, print string literal token is equal to star coder 2 dot tokenizer dot decode that token. So let's run this and see. Yeah, if you can see the output, so it has generated the list of tokens, and see what set of characters are equivalent to that code. So 684 is DEF and 17966 is the other token that is equal to space and hello. 100 is equivalent to the underscore. Yeah, it is the hello, right? Yes, hello underscore world, that is that underscore. And next is the world, then the open parenthesis, the closed parenthesis. So this star coder tokenizer has taken these set of characters to be that token. So this is all about how the tokenization is performed in the code. and we have also seen how different kinds of tokenizers and how their tokenization process goes with the text, and we have also worked on how it converts the text into numerical representation, which is the tokenization. So this is all about the tokenization. I hope you all have found this tutorial interesting. That's it for today's session. We learned what tokenization is, why it is important, how to load and use pre-trained tokenizers, how to encode and decode text, what are the different types of tokenizers, and tokenizing code for AI-based programming models. If you found this video helpful, please like, share and subscribe to our TechArt Learning Hub for more exciting tech content. And also please don't forget to check out the techartdeals.com website for creative products. See you in the next session.